Hi, this is your Chapter 4 demo program. In this program, this chapter, we're not only going to do the IPO chart and the desk checking, but we're actually going to write code and put it into a C++ program and execute it and run it. So we're actually going to write a program this week. So here's our problem specification. A1 Appliances needs a program to allow store clerks to enter the number of dishwashers in stock at the beginning of the month, the number purchased by the store during the month, and the number sold to customers during the month. The program should calculate and display the number of dishwashers in stock at the end of the month. So that's our problem specification. Then it tells us to create an IPO chart for the program and perform the desk check using 5,000 as the number of dishwashers, 1,000 as the number purchased, 350 as the number sold. So this desk check part, okay, when they talk about desk checking, this part, those numbers go down here. That's where we're going to test. They're not part of the program. They don't belong in here. That's a very common point of confusion in the beginning when people start writing these programs. They want to put this desk checking data in the processing part of the program, and that's not where it belongs. So don't get those two confused. So what do we do when we start our IPO chart? We start with the output. So as we go through and read this, we're looking for the keyword display. Okay, calculate and display the number of dishwashers in stock at the end of the month. That's our output. So what do we find next? Our input. So as we read through, allow the store clerks to enter. That's my keyword. Number of dishwashers in stock at the beginning of the month, the number purchased by the store during the month, and the number sold to customers during the month. Those are all the things that will be entered. So that's our input. So I came down here and I put words, beginning dishwashers, purchased dishwashers, sold dishwashers. That's what's going to be input. And then I put the name of the output, the ending dishwashers. So this is what I have to calculate. When we do the processing, we do input, process, output. So the input is having the user enter these three things. And that's what we did here. Beginning dishwashers, enter the beginning dishwashers. Purchased dishwashers, enter the purchased dishwashers. Sold dishwashers, enter the sold dishwashers. Now we have to calculate, input, process, that's our calculations. Calculations, we figure out the output. So whatever is over here needs to be done in the calculations. So what is ending dishwashers? Well, think about that for a while. Okay, it's my beginning dishwashers, whatever I have to start with, plus whatever I bought, minus what I sold. I think that's right, but we'll try that with the desk checking to make sure that it's the right algorithm. So that's my calculation. So once I've calculated my output, the things I need to display for output, then I display it. So we have our input, get the input from the user, the processing or the calculations, and then the output. We display what we calculated. If we come down to the IPO, to the desk checking part of it, these are the numbers we can plug into our formula. So if I say 5,000 is my beginning dishwashers, okay, 5,000 plus my purchased dishwashers, that's 1,000, minus my sold dishwashers, 350. Use a calculator to figure that out, and I came up with 5650, and that is correct. So my calculations here are producing the correct output. So that's my desk checking. Now, here's where we're going to translate it into code. So all I did was I copied these variables from my IPO chart down to here. Okay, so there's the three from input, and here's one from output, and I copied them down there. I'm going to do my variables first. Then my instructions. So these are the instructions from the IPO chart. I just copied them straight down here. Nothing fancy. Just cut and paste. Now over here in the instructions, I have to translate this IPO chart information into real C++ code. So first thing I do is I define my variables. Beginning dishwashers. Well, I can't use that name. It has a space in it. And really it's kind of long. I want something that's short but descriptive. So C++, when I define a variable, I have to give it a data type. I use the integer data type. The int is a keyword that stands for integer. Dishwasher should be a whole number. I'm not going to sell a half a dishwasher. I'm not going to buy 3/4 of a dishwasher. It's a whole number, so I'm going to use integer. So int for the type of data, and then the name. To me, begin DW made sense. Okay, it was short enough but descriptive. Okay, you're going to come up with different names. That's fine. Everybody's going to come up with their own naming scheme. Then I initialized it to 0. So I want to empty that variable out. Make sure that there's nothing left in that piece of memory from a previous run or other calculations. Did the same thing for my other variables. Purchased dishwashers, sold dishwashers, and ending dishwashers. They should all be integer type data. Gave them names following the rules of the C++ language. No spaces, doesn't start with a digit. Underscores are allowed, but I didn't use any underscores. And initialized all of them to 0. That's good housekeeping. Now, coming down to the instructions. Enter the beginning dishwashers. Well, there's two parts to getting data from the user. You have to prompt them. You have to tell them what you want them to enter, and then you have to get that data from the keyboard. So this statement, this cout statement, if you remember from our Hello World program, this will display what I have in quotes on the screen. So cout stands for console out. My operator that directs the following to that cout command. Whatever is in the quotes here is going to display on the screen. So exactly what's in the quotes, the text, enter the number of dishwashers at the beginning of the month, exactly as it looks there, will display on the screen. I end my statement with a semicolon. That is my prompt. Okay. Then, after I prompt, I get the data from the keyboard. I allow the user to enter the data. So the cin command takes the data that the user enters from the keyboard and places it into this variable. So after we do that, begin DW is no longer equal to 0, unless they entered 0. Okay, so whatever the user entered, say they entered 5,000, that is now the value of begin DW. Have to do the same thing for the other two pieces of input. Enter the purchased dishwashers, enter the sold dishwashers. Okay. Prompt, use my cout to prompt the message that I want to display on the screen that the user will see, and then get the data from the user. Okay. And again, prompt, message that I want the user to see, and then get the data from the user. Here's my calculation. The ending dishwashers is the beginning dishwashers plus the purchased dishwashers minus the sold dish for that matter. This is a replacement algorithm. You're always going to have what you're calculating on the left. An equal sign, or your assignment operator is the real name for it, and then your formula on the right-hand side. The formula will be evaluated or performed, and then the results will be placed into this variable. It's not like regular algebra where it balances out on both sides. This is calculated, the results of the calculations are placed in here. It doesn't matter what's in here to begin with, it's just going to be replaced. Okay, so after we've done our calculations, then we can display our output. So display ending dishwashers. It's a cout statement again. Cout will display things on the screen, and I'm displaying this string of text. The number of dishwashers at the end of the month is. And then I'm also going to display the variable NDW, so what I calculated. So that should put the text, the number of dishwashers at the end of the month is, on the screen, followed by whatever the value is that's been stored in this NDW. Now I'm going to take this and I'm going to copy and paste this into a C++ program. If you're going to do the same thing, if you're going to copy and paste from Word, something that is going to make your life a lot easier is to change some of these autocorrect options. So to change the autocorrect options, I go to the File tab, and then I go down to Options, and it's Proofing, and then Autocorrect Options. I'm going to go there. Now, two things I want to do. Actually, three things. I'm going to make sure that hyphens are not replaced with a dash. Okay, I want my minus sign to be my minus sign when I type it in. I don't want it to replace it with a dash. I also want to be sure that I uncheck straight quotes with smart quotes. I want the quotes to stay the same. I don't want them to replace them with the smart quotes because that's going to cause errors when I copy it over. And let's see, what else should you do? Turn off these two, capitalize first letters of sentences and capitalize the first letters of table cells, so you're not getting capitalization automatically where you don't want it. So that will make it easier when you go to cut and paste. You won't have errors that you have to correct. So, I'm going to start up Visual Studio. And if you remember how we do this, we start a new project. We make sure Visual C++ is expanded. We choose Win32, Win32 console application. I have to give it a name. A place to store it. Be sure create directory for solution is not checked. And once you do these, expand Visual C++, Win32, Win32 console, your location, that's a default that's going to remain the same. It's not going to change. So you don't really have to do that every time. But the first time through you do have to choose those things. Name you'll have to change every time. Click OK. Application settings, this one you have to do every single time. So you want to be sure you choose empty project. Very important. And then I can finish. And it's creating a blank project for me that I can add source code to. Now I'm going to right click on source files, choose add, new item, and I want to be sure C++ file is selected, the .cpp, give it a name. It can be the same as your project, but it doesn't have to be. And there we go. I'm going to start out with my comments. Who wrote it? The date I wrote it. Something about it. Now I can start my code. My include files. I'm going to include IO stream. As we go along, you're going to learn that there's others that we can include also, but at this point we're just including IO stream. Add the using namespace std, and then my int main, my main function, which every program has to have. Oops. My curly braces to mark the beginning and the end. Housekeeping, my end of job housekeeping in here. So this is basic shell of a program. Every program is going to have this framework, and then we're going to put our code into it. So main is the name of the function that every program must have, lowercase main. Okay. Integer is the type of data it will return. When this program is run, the main function is called by the operating system. When the program ends, control returns to the operating system. So operating system calls the program. When the program's done, control goes back to the operating system. The function main is going to return a piece of data. This int says that the type of data that will be returned or passed to the operating system is the type integer. This last line here returns 0. That makes the program end, and it returns the number 0 to the operating system. 0 is an integer. That's how those two tie together. This line cout endl is just to give me some spacing at the end of my program, so before this push any key to continue message shows up. Okay. This is a basic framework of a program. Okay, so I actually don't type this in from time to time. I have it on a sticky paper on my desktop, and I just cut and paste it in. Okay, so I have this in. I am going to compile. just to make sure I did it correctly and I don't have any errors. We have a saying in programming, compile early, compile often. You really want to compile pretty often. As you put in a couple of lines of code, compile it and test it. It'll make it easier for you to find your mistakes than if you type in, 1,000 lines of code and then compile and a whole bunch of error messages come up. If you type in 5 lines of code, compile, some error message come up, you know it's in that 5 lines you just typed. Makes it a lot easier to find it. Okay, now I'm going to go into the Word program and I'm going to take what I typed and where to go? Copy and paste it in here. And notice how it color coded. My keywords, int or blue, that's good. The things that are within quotes, my string constants that will display on the screen, are red. Okay. My operators are blue. So this color coding starts to make it easier for you to see your errors. If I would have cut and pasted this in and this wasn't red, I would have known I had a problem. If I'm cutting and pasting from Word, probably the problem is I have the smart quotes turned on. It's not the right character. So we've got this in. Let's see if it works. I'm going to start without debugging. That compiles it. Remember, every time I make a change, I have to compile. Oh my goodness. So now I can try this. And I should try it with my desk check data. And if the answer comes up the same as my desk check data, then it's good. So this one really seems like it works. You can also try it with other numbers, like things you can do in your head. So debug, start without debugging. So say I had 10 dishwashers and I bought 5 dishwashers and I sold 1 dishwasher. I should be able to do this in my head, 14 dishwashers. So I know it's working. Now the other thing I need to put in this is comments. These are notes to me or somebody else further down the line, whoever's going to work on this program. The comments make it more readable. And there's not too much to say about this program because it's not all that complicated yet, but just putting some comments in there to break it up. Some people get fancy with this and make nice little lines, make it stand out a little bit more. But that's personal preference, whatever you like to do. I do expect you to put comments in, but I'm not going to get too fussy over how you format them. As your programs get more complicated, what I like to do is I like to put comments out on the side. So what I usually do is I'm going to have like a column, 2 columns, a column where I have my code over here, and then a column over here where I have my comments. So the idea is I should be able just to kind of read down through the comments and get an idea of what the program's doing. Again, when a program is really simple like this one, you don't need as much commenting, but as your programs get more complicated, you really do need these comments. Your programs can be in production or used for many, many, many years. They're going to have to be modified over time, so you need these notes for you or another programmer down the road that's going to have to modify your programs. So that is your Chapter 4 demo program. I hope this helps to make a little more sense out of it for you. If you have any questions or problems with your code, please email me and I'd be happy to help you.